Now that we have those two tables readily available, let's look at some of the properties of these tables, and then we're going to look at examples on how to use these tables. So the first thing to notice, if you go to the table called just table 4 with the negative z-scores, the cumulative area is close to 0 for z-scores close to z equals negative 3.49. To make heads or tails of that, you find in the column underneath the z the negative 3.4, and then in that row you find where it has 0.09. So essentially that number that it provides you is 0.0002. Make sure that you're looking at the correct chart and getting the same number. So essentially the area underneath that curve is going to be 0.0002, which is very close to 0. As you move through this chart, going from being negative 3.49, getting closer and closer to 0, and then passing 0 and moving towards positive 3.49, the cumulative area increases as the z-score increases. So it's picking up more and more area as you're moving along. If you go to where it says negative 0.00 in the negative chart, that's the bottommost row, rightmost column, it says 0.5. So the area to the left of z equals 0, which is the mean, is 0.5. And remember that the mean is smack dab right in the middle of our data set. And so it is 50% of the area is to the left, 50% is to the right. And then as you keep moving, since your z-score or your cumulative area keeps increasing as your z-scores increase, if you go all the way out to 3.49, so we're in the positive chart, in the z column we go to the very, very bottom of that, and all the way to the very far right, for 3.49, we get 0.9998. So the area to the left of z equals 3.49 is going to be 0.9998. All right, so those are just some properties of the standard normal distribution. We're going to figure out how to use this thing effectively. Our first question is to find the probability that z falls below 2.74. So we want to find the probability that z is less than or equal to 2.74. And to do that, we take our chart that has the positive numbers. We find in this leftmost column 2.7, and then we go over to the column that is marked 0.04, and we end up getting 0.9969. So that is our answer here, 9969. All right, so the probability that your z-score is less than or equal to 2.74 standard deviations above the mean is about 99.69%. Next, we're asked to find the probability that z falls below negative 0.93. So again, we're looking for the probability that z is below negative 0.93. And for this, we have to move to the negative chart. So we're looking at the chart that has the negatives along the left-hand column. We go to negative 0.9, negative, and then we go over to the column that has the 0.03. And we should be getting 0.1762. Right, so again, we go to the row marked negative 0.9 and the column marked 0.03 to make this negative 0.93. And you find where those row and column intersect, and that gives us this number of 0.1762. The next question is to find the probability that z is at least 0.62. So we want the probability that z is at least 0.62. And here comes something that we have to make sense of. So again, we're going to use this positive chart. But notice that the picture at the top, the area is always shaded to the left. And to the left is always the less than. If we want the area to the right, so this area over here, you have to think about it in terms of complements. So instead of figuring out what is the probability that z is strictly greater than 0.62, what we can do is find the probability that z is less than or equal to 0.62, and then do 1 minus that. Because remember, the total area, so if we're looking at this picture, the shaded region and the unshaded region, the total area is 1. So if we want to find the area of the unshaded region, we can do 1 minus the area of the shaded region. Now we're going to go to the 0.6 row and the 0.02 column. We get 0.7324. So we have 1 minus 0.7324, which once you do that subtraction, you end up getting 0.2676. So the probability that the z-score is greater than 0.62 standard deviations above the mean is roughly about 26.76%. Likewise over here, because we want to find the probability that z is greater than or equal to a value, our z normal distribution chart only tells us areas in terms of less thans. And so to take a greater than and turn it into a less than, we do 1 minus this. And just for practice, try to find this value on your own. Okay, so if you haven't found it yet, pause the video and try to find it. Otherwise, let's keep going. So we go to the negative chart, right? So the other page, the one that doesn't have the continue on top. And we find the negative 2.6 row, and we go to the 0.00 column. And we should be getting 0.0047 as that number inside the chart. So that will give us 0.9953 as our answer. And next, we want to find the probability that z is in between negative 0.24 and 0.43. And again, our table tells us things that are solely to the left of a value. And if we were to draw a little bell curve to make sense of what we're being asked to find the area of, we have negative 0.24, which is going to be, let's say, over this side. And then we have 0.43, which will be over here. Because remember, right in the middle is mu, which is 0. Now, if we go ahead and find the area to the left of 0.43, that's going to give us everything to the left. But we don't want anything that's past here, right? So we need to stop at negative 0.24. And so to get the area in between, we can find the whole area to the left of 0.43. Then we can find the area to the left of 0.24. And then we just take away this area from the whole area, and that'll just leave us with this region here. All right, so we're going to find the area to the left of 0.43. We're going to find the area to the left of negative 0.24. Then we're going to take the difference of those two, right? Because the difference is going to be everything that's between 0.43 and negative 0.24. If we go into our chart, the probability that z is less than or equal to 0.43 is going to be 0.6664. And the probability that z is less than or equal to negative 0.24 is going to be 0.4052. And so if we take the difference, we get 0.2612. Next, let's say we want to find the probability that z is equal to 1. And there's a couple different ways we can interpret this. First, we can do like what we did in 5. So we need to find the probability that 1 is less than or equal to z, which is less than or equal to 1. And if we split this up, we end up getting that the probability of z is less than or equal to 1 minus the probability of z is less than or equal to 1, which doesn't matter what the probability of z less than or equal to 1 is, since we're subtracting it off right away, we should be getting 0. That's one way to think about it. The other way to think about it is we're looking for areas under a curve. And if we're looking for just z equals 1, then we are looking at just essentially calculating, here's the number 1, we need to figure out the area of this line segment. Right. So it has a height, but its width is 0, which means that if you did the base times height or the length times width for a line segment, you end up getting 0 for that area. You could do the subtraction over here, or you can think of this as the area of a line segment. Right, both are valid ways of thinking about it. Now, if we want to find the probability that z is less than or equal to negative 4, if we look at our chart, the smallest value or the most negative value that we can look at is negative 3.49. And we know that as we move further and further to the left, our area should keep getting smaller and smaller and smaller. Right? That's one of the properties, or how you can interpret one of the properties a little bit differently. So since negative 4 is less than negative 3.9, and it's actually quite a bit less than in the world that we're looking at, this should be roughly 0. Like really, really, really close to 0. Now notice that for 8 and 9, things are going to be a bit different on how we approach these problems. For questions 1 through 7, everything was the probability of z compared less than or equal to, greater than or equal to, whatever you want, to a number on the inside. And since we were looking at a number on the inside of the probability, we went to the outside of the chart. Down here, we're trying to find x, so the thing on the inside that is equal to this number here, this 0.9222. Which means we need to flip our perspective around. We need to go into the chart to then find where 0.9222 is, and that row and that column is going to tell us what the x is. First and foremost, 0.9222 is larger than 0.5. which means if you're trying to decide, are we with the positive z's or the negative z's, since 0.9222 is greater than 0.5, we know that x has to be greater than 0. And so we're going to be looking at this chart here, where it has the positive z values. And we're looking for 0.9222. So we're going to come into the chart and just start looking for 0.922. Right, so you just kind of start moving around. Looking, I got 0.9207. Next one over is 0.9222. So that is in the row marked 1.4, in the column 0.02. So altogether, the z-score, which gives us about 92.22% of the area, is going to be 1.42. That is our x value. So let's try that again with finding the first quartile for a standard normal distribution. So Q1 corresponds to 25%, which means when we set this up with symbols, we're looking to find our x value, for which we get 0.25. Now again, because 0.25 is less than 0.5, we know that x has to be a negative number, right? Because less than half of the area is to the left of that x value. So we come over to our chart that has the negatives. We go into our chart and we look for 0.25. So we're moving around. And where do we see that? We don't have an exact answer, but when we look here, we have 0.2483 and we have 0.2514. So 0.25 is somewhere in between these two numbers. And we're going to take the number that's closer to. So over here, this is 0.0017 away from 0.25. Over here, this is 0.0014 away from 0.25. So this number here, the 0.2514, is closer to 0.25 than the other number is. And that's occurring at negative 0.67. So our x value is negative 0.67. But we were off by just a little bit. And so we're going to take our Q1 is going to roughly be about negative 0.67. It's probably closer to negative 6.75, just because those two numbers that we were deciding between are almost about the same distance away from 0.25. There's a little bit of discrepancy, so that's where this approximately comes into play.